This is part 2 of our DTaP talk, and we'll be discussing its second component, tetanus. Tetanus is similar to diphtheria in a way. It's a disease that develops due to a toxin, so let's jump ahead into it. The pathogen responsible for the disease is called Clostridium tetani. It produces two toxins, tetanus plasmin, which is the main toxin and the one we'll cover in detail, and tetanolysin, a less important one, so we'll not focus on it. Clostridia are anaerobics, meaning they can only survive and reproduce in oxygen-empty environments. In an oxygen-containing environment, they turn into spores with very minimal metabolic activity to preserve themselves. And normally, Clostridia live in GI tracts of humans and animals. Like we discussed, the source of infection can be either human or animal. Since Clostridia require specific conditions to reproduce, they generally form colonies in already infected surfaces with poor oxygen supply, or other bacteria can actively consume oxygen for them so that they can survive. Open fractures, bullet wounds, and soft tissue infection are very common places for Clostridium tetani to live. So when we're talking about the source of infection, it's not actually human or animal hands or feet, it's actually the soil that contaminates wounds. To understand the clinical manifestation and the toxin a little bit better, let's take a brief look at how nervous tissue works in general. The hard-working part of it is comprised of neurons, which communicate with each other by using axons and dendrites. Dendrites are used to receive information and axons to give it. The way information is passed from one neuron to the other is through mediators, and mediators can either excite other neurons or inhibit them. Normally, there is a balance between excitatory and inhibitory forces. Certain conditions are characterized with tipping this balance. Alcohol, for instance, is a nervous system depressant. It causes neurons to receive signals at a slower pace. Alcohol withdrawal, on the other hand, is caused by a rapid decrease in inhibitory mediators, so our nervous system rapid fires excitatory mediators. Tetanus plasmin is a toxin which disrupts our neurons from communicating inhibitory signals to each other. The incubation period for tetanus can range from 1 week to several months. It depends entirely on how far the source of Clostridia is from the central nervous system. The most common form of tetanus is generalized, involving the entire body. It usually presents from top to bottom. Facial spasms, locked jaw, neck stiffness, arm muscle rigidity, body muscle, and finally leg muscle rigidity. Spasms occur frequently and can last for several minutes. A very characteristic position for patients to take is called opisthetonus. The mildest form of tetanus is local. It's limited to the wounded part of the body and manifests as muscle tremors and cramps. It can progress to generalized, but it is very rare. Another form is cephalic tetanus. Muscle rigidity is limited to the head in this case, and it can progress to generalized form as well, which has very high rates of mortality, in this case up to 30% of cases. Well, muscle rigidity can generally be managed pretty well these days, but unfortunately it causes a lot of damage to the person's neuron system in the process. In principle, the vaccine is the same as diphtheria. It's an anatoxin, meaning it has been inactivated chemically and has no biological activity. What we're simply injecting is a dummy, and our immune system can react to it. And in a similar fashion, it's also a rather weak antigen, so the vaccine is combined with diphtheria to revaccinate every 10 years, which is known as DT vaccine. No special mentions here, all of the side effects and contraindications are the same as the common ones. While not being the most common infection, it's one of those preventable diseases with high mortality rates that we can potentially avoid. Even the people who survive are left with muscle weakness and tremors that can take a lot of time to recover. It's also much simpler to vaccinate people against it rather than treat those patients, as they often require extensive periods of very intensive care.